I'm just going to walk quickly through a few questions that you're going to see this week, and you should have already read the chapters, so all of this is familiar to you. And we're asked to determine the probability that a senior executive will report a 4 or a 5 on the job satisfaction score. And then we're also asked, what about a middle manager? How probable is it that a middle manager is very satisfied? And then we're asked to compare a senior and middle manager to determine who has the higher job satisfaction. So to do that, I've put the numbers from the question in Excel, and these are percentages, and they do equal 100%, which makes the math very, very easy. So to determine my middle manager is this column. So I've got C7 divided by 100. And so on and so forth. So then the next number, and then I will do the same for the senior manager. So once the chart is filled in, the probability that a senior executive will report a 4 or 5, well, I'm just going to take the senior manager and I'm going to add the percentage because it's the probability. So I'm going to add the percentage of rating a 4 and rating a 5. Probability a middle manager is very satisfied, which is a 5, is going to be that value there, 0.29% probability. And if you're asked to report these in percentages, then just multiply by 100. Then it asks us to compare a senior manager and a middle manager to determine who is the most satisfied. So to do that, I'm going to use the function sum product. And my array 1 is going to be A2 to A6. And then for my senior manager, it is going to be E2 to E6. And then for my middle manager, again, I'll sum product. And I'll say A2 to A6. And then my array 2 for middle manager is D2 to D6. So by looking at these values, it looks to me that the middle manager is more satisfied than the senior manager. You read about the Poisson distribution, and I was asked to find f when x is 2, f when x is 1, and then p when x is greater than or equal to 2. But in order to find this value here, I also need to know f when x is 0. So I've added that in. And the problem told me that my mean was 6. So insert function, Poisson distribution, x2 mean 6, and in this case my cumulative is false. And I'll do this again with the value of x being 1. My mean is 6, value is false. And then I will find for 0. Now to find this value of p when x is equal to or greater than 2, I'm going to take 1, which would be the total sum, minus f when x is 0 and minus f when x is 1. And so my answer is 0.9826. You also read about continuous probability. Take those values out. And I was given a question that said that a manufacturer manufactures 1,000 units with a mean weight of 10 ounces and a standard deviation of 0.36. And it said if an item weighs less than 9.64 ounces, okay, or greater than 10.36 ounces, what is the probability of defects? And then how many units would that be? So what we want to do here is we want to find the normal distribution. Norm dist. And the first one, my lower limit is 9.64. My mean is 10, given in my problem. My standard deviation is 0.36, also given in my problem. In this case, my cumulative is true. I'll do the same thing for the upper limit. Now I'm going to put in 10.36, mean of 10, standard deviation of 0.36, and true. Now, my probability of defects. So to find this value, I am going to say 1 minus, similar to the previous problem, except I need this value. I need to have the sum of 1 minus the sum of. So I've got to have that parenthesis there. So, and I need equal, don't I? So 1 minus the sum of my high value minus my low value. So my probability of defects in that range is 0.3173, or we could say 32%. And then based on if we manufacture 1,000 units, how many of those are going to fall into this range? And to find that, we're just going to say equals 1,000, because that is how many units we're talking about, times the probability. There'll be 317 units. Lastly, this week, I'm going to talk about exponential probability density. And you were given the formula in the book, and you need to know the formula to work this one. So you don't need to commit it to memory, but you need to know what you're referencing for the problem. So based on this formula, I know that my denominator in both cases is my mean. And I was given this equation and asked to find these values. P when x is less than or equal to 2, less than or equal to 5, less than, or yeah, between 2 and 5, and then greater than or equal to 3. So I need to know what my mean is. In this case, it's 5, because I need that to plug in this formula. And that's what we're going to do here. We're actually going to have to plug in this formula. So this is how it works. Equals 1 minus exp. Then I have negative, say right here, the negative mean, which is 5. I'm sorry, negative x, which in this case is 2, divided by the mean, which is 5. Sorry about that. Okay, so I'll work that same formula again here. So it's 1 minus exp, negative 5 divided by the mean, which is 5. Again, I didn't put my equals. Bad habit I have. Okay. Then to find the value between the two, we're simply going to subtract the larger from the smaller. So we're going to say when P is less than or equal to 5 minus less than or equal to 2. And that's the answer. Now, in this one, because now I'm working the formula for when x is greater than, the formula is just a little bit different. So what I'm going to do is I'm going to say 1 minus, put my equal 1 minus, then in my parentheses, I'm going to say 1 minus exp, and I didn't put my equal to, did I? Equal 1 minus exp, and then negative 3 divided by 5. Yeah. Oh, I needed 2 parentheses at the end, but it'll fix it for me. So that one was a little bit different. So I put 1 minus in front of the whole equation that I used up here to get the value. So I hope you found this video helpful. If you have any questions when you're working through your assignments, please reach out to me and let me know.